Tonight's homework topic is exponents and place value units. Here are your two learning objectives or learning targets for tonight's homework. Make sure you copy these down in your composition notebook. Remember, you can stop the video and catch up with me as needed. First target, there's that typo again. Use place value relations to find products and quotients of powers of 10. I can use exponents to name place values and explain patterns in placement of the decimal point. All right, let's state the unit as a decimal with a little fluency practice. 9/10 be written with a decimal point and the number 9. 10/10 is actually going to look like this. 1, or you can also write it 1 with a decimal and a 0 after it. 11/10, 12/10, 18/10, 28/10, 58/10. 9/100 is going to look like this. 10/100, 20/100, 60/100, 65/100, 87/100. Make sure you're getting these down in your notes. If you haven't been taking notes on these with examples, go back to the beginning of the video, start taking notes on these. All right, a little trickier. 108/10. So we've got to break apart our place value places. It's going to look like this, 11 8/10. All right, let's put this into practice. Jack and Kevin are creating a mosaic by using fragments of broken tiles for art class. They want the mosaic to have 100 sections. If each section requires 31 5/10 tiles, how many tiles will they need to complete the mosaic? Explain your reasoning with the place value chart. So let's go ahead and put our number, 31 5/10 here. We remember they're going to have 100 sections with 31 5/10 tiles, so we're going to be doing multiplication, which means we're going to be moving to the left by 2 place value sections. So 1, 2, 1, 2, 1, 2, and we're going to need a placeholder here. So they are going to actually need 3,150 tiles. All right, let's do a little concept development with multiples of 10. We're going to use this chart. Here we're going to start with 10, 100, 1,000, 10,000. I have 10 times what is going to equal 10? 10 times 1 is going to equal 10. Now what times 10 is going to equal 100? You know your multiplication facts, you'll know that 10 times 10 equals 100. Right, so if I use only 10 as a factor, how could I multiply to get to 1,000? If I know that 10 times 10 is 100, 100 times 10 is going to be 1,000. They said only use 10 as a factor. So I'm going to look at 10 times 10 times 10. Put that up here. Now, using what we did in the last slide, if we're only using 10 as a factor, how could you multiply to get to 10,000? Well, if 1,000 was 10 times 10 times 10, then 10,000 would be 10 times 10 times 10 times 10. Those boxes aren't big enough. So 10,000 would equal 10 times 10 times 10 times 10. So how many zeros are in our product 10,000? If we count them up, 1, 2, 3, 4, there are 4 zeros. Should be noticing a pattern. the pattern is that the number of zeros is the same on both sides of the equation. The number of zeros in the product is the same as the number of zeros in the factors. So here's our product and here's our factors. So I see 4 zeros on the left and 4 zeros on the right. The 1 moves one place to the left every time we multiply by 10. So it's just like a place value chart. Each number is 10 times as much as the last one. So if we use this pattern, how many factors of 10 do we have to multiply to get to 1 million? So I'm going to write up here instead of the chart because it's not big enough. And we know that both sides of the equation should have the same number of zeros. So I've got 1, 2, 3, 4, 5, 6 over here. So that means I've got to have 10 times itself 6 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 10 times 10 times 10 times 10 times 10 times 10 equals 1 million. Now that's a lot of work to keep writing 10 times 10 times 10 times 10 over and over and over again. So mathematicians have come up with a term called an exponent to represent how many times we use 10 as a factor. Here's the word exponent. You've probably seen it before. For example, if you see something that looks like this, 2 is the exponent. It's a little bit smaller up at the top, and that just means that we're multiplying 10 times 10. Now, to sound like a mathematician, you would read that 10 to the second power. You wouldn't say 10 with an exponent of 2, 10 to the second power. All right, so let's look at the problem below, 10 times 100, and let's see if we can express it using exponents. So first of all, I know this is 110. 100 is going to be 10 times 10. So if I've got 10 times 10 times 10, this is going to be written with an exponent as 10 to the third power. Now make sure that your exponent is smaller and it's above the number. Do not want to write it so it looks like this. It's very confusing. It's also incorrect because that's the number 103. Alright, so to work this problem, we've got 10 times 10 is going to equal 100. 10 times 10 times 10 is going to equal 1,000. We've got 1, 2, 3, 4, 5 multiples of 10. So I'm going to write that 10 to the 5th power. Now, very important that you do not confuse 10 to the 5th power with 10 times 5. They are not going to be the same thing. 10 times 5 is going to be 50. 100 times 1,000 is going to be 100,000. Big, big difference. All right, 10 times 1,000. We've got 1,000 is going to be 10 times 10 times 10. 1, 2, 3, 4. 10 to the 4th power. Right, so let's compare this expression to the ones we've already talked about. The other ones only had powers of 10. This one has a factor other than 10. So let's first write 3 times 10 to the 2nd power without using an exponent, So we could say that's 3 times 10 times 10, or 3 times 100. So the product of this, 3 times 100, is going to be 300. So if you know that 3 times 100 is 300, then you're going to also know that 3 times 10 to the 2nd power is 300. 10 to the 2nd power and 100 are the same amount, so the product is going to be the same. So we're going to use what we've learned about multiplying decimals by 10, 100, and 1,000, and your new knowledge about exponents for the next slide. Right, we can certainly use this with our place value chart as we have before. So we're going to put our place value, or our number in here, factor in here. 10 to the 3rd power is going to be 10 times 10 times 10, which is also going to be 1,000. So I'm going to, since I'm multiplying, move each digit over 1, 2, 3 places. 1, 2, 3 places. and then I'm going to need to add in my placeholder zeros. So 3 4/10 times 10 to the third power, which is also times 1,000, is going to be 3,400. All right, let's do the same thing here. 4 21 thousandths times 10 to the second power, which is going to be 100. So since I'm multiplying, I'm going to move 1, 2 place value boxes over. 1, 2, 1, 2, 1, 2. And so my answer, whoops, is going to be 402 1/10. All right, let's try some division. We're going to write 700 divided by 10 to the second power without using an exponent, and we're going to find the quotient. So we can rewrite this as 700 divided by 100, because 10 to the second power is going to be 100. 700 divided by 100 is going to be 7. Let's try this one with a decimal. So 7 1/10 divided by 10 to the second power, which is 100. I'm just going to move my place value over 2 places to the right because I'm dividing. So my answer would be 7,100. All right, let's look at some patterning. We've got 43 thousandths, 4 3/10, 430. So we've got to try to figure out what the pattern is so we can complete the last 3 boxes. Looks to me like the 4 is moving 2 places to the left. So each number is being multiplied by 100 to get the next in the order, the next one. Each number is multiplied by 10 twice, so each number is multiplied by 10 to the second power. So let's finish this off. So we've got 430 here. Next is going to be 43,000, then 4,300,000, 430 million. If you need to pull out your place value chart to check this out, please take time to do that. Now in this pattern, it looks like the value of the 6 is changing. It's getting 100 times smaller every time. So we're dividing by 10 twice, or by 10 to the second power. So we're going to move from 6,300,000 to 63,000. Try to squeeze it in here. 630, 6 3/10, and 63 hundredths. All right, let's do a little writing in exponential forms. And we're going to look at the number of zeros, 1, 2, 3, 4. So this would be 10 to the 4th power. 10 to the 3rd power. 10 to the 2nd power. 10 to the 4th power. 10 to the 6th power. This is also going to be 10 to the 6th power. Right, in your composition book, I want you to work these 4 problems. Write the following in standard form. For example, 5 times 100 equals 500. Explain the pattern used to place a decimal in the answer when you multiply or divide a decimal by a power. Please be ready to discuss this when you come to teacher table tomorrow during math class. All right, let's complete the pattern. I'm just going to go ahead and write the answers in, but you need to be ready to discuss this with me tomorrow at teacher table. Explain to me what the pattern is. Same with this one. And what pattern did I follow here? The remaining sections of this video are your exit tickets. Just like we've done the previous 2 days, you will need to work these in your composition notebook, have the answer ready to fill in tomorrow when you take your quick check quiz at the beginning of class. Good luck. Now remember, if the slides move too quickly, you can always stop the video and work through the problem and then start it up again when you're ready. If you have finished this problem and worked it in your composition book, then you are done with your homework for tonight.